To take the derivatives of these two very similar looking functions, we actually have to use two very different rules. And the rule that we need for each case is dictated by where the x is. And so for this first example, we see that the x here is in the exponent. And so since the x is in the exponent, we're going to be needing to utilize the derivative of an exponential function. And so basically this function is of the form e to the u. So when we take the derivative, we've got the derivative being, the derivative of e to the u is itself e to the u, so that would be e to the power e to the x. But then since that exponent wasn't simply x, but rather a function of x, we've got that we have to take the derivative of that exponent also. So that exponent is e to the x. So to finish off this derivative, we've got f prime of x equals e to the x, and then we have to multiply by the derivative of e to the x. Well, the derivative of e to the x is itself because the exponent is simply x, so we don't need a chain rule for that part. So now to use some algebra exponent rules to clean this up, we see that we have base e for both of these terms that are multiplied together. So since we have base e shared, we can use exponent rules that tell us when we have multiplication, we add the exponent rule. We add the exponents. And so the exponents then are e to the x plus the x from the second term. And so the derivative, let's go ahead and put the prime there for the derivative. The derivative, f prime of x, is e to the power e to the x plus x. And so that takes care of the derivative of the first example. Now when we look at the second example, we see that the base itself is e to the x. So the x is living in the base. So the function here is of the form u to a power. Now that power happens to be e, and that's not something that we always see. E is not the prettiest sort of number. It's not an integer that we usually see when we're dealing with power rule problems, but e is still just a number. So we see the function e to the x, which is our u, that we'll use for the chain rule. That's in the base. We've got the e to the x for the base, and then the power e is up top. And so when we're taking the derivative here, we've got the power rule. So we have f prime of x equals, and the power rule tells us that we bring down the exponent, so the exponent is e. We take the exact same base that we had, and that base is e to the x, and we have as the new exponent one less than what we had before. So it would be just e minus 1. Now we're not done here at this point with the derivative because the inside function there, the base, wasn't simply x, the base was a function of x, and so we have to use the chain rule to finish it off. So we've got the derivative of the base, which is the derivative of e to the x, to finish the derivative. So we have f prime of x equals, we have e times e to the x raised to the e minus 1. And then we have to multiply by the derivative of e to the x. The derivative of e to the x is itself, and so that completes our derivative. However, we actually have base e everywhere, and so we can again use some exponent rules for algebra just to make this look a little bit nicer. So the first thing that I'm going to do is get rid of those extra parentheses here. We have the base e raised to the power x, which is then raised to the power e minus 1. And so whenever we have a power to a power, we multiply the exponents. So we have that e that's out front times, we've got e to the x multiplied by e minus 1, because that was the power to a power means multiply the exponents. And then we have e to the x here. So now you see we have three terms multiplied together that have base e. So we can combine those three terms by adding the exponents. So we have base e overall. In that first term there, we have an understood power of 1. Then we add to it the exponent from the second term that's multiplied. So that exponent was x times parentheses e minus 1. And then we add to it the very last exponent that we have, which is x. And so yet again, we can do just a little bit of distributing and combining like terms, simple algebra steps, to write this nicely. So we have the power e as our base, and then we have a 1 plus, and we're going to go ahead and distribute this x across the factor e minus 1. So I'm going to write it as e times x so that the coefficient e, the number, is sitting in front of x. That's what we typically see. And then we've got to distribute that x across the subtraction. So we have minus x. But we have the plus x that is sitting at the end. And so in the end, we've got a minus x plus x that would cancel, leaving us with the derivative f prime of x equals the base e to the 1 plus e to the e times x. And so we have our final derivative for this case using the power rule.